Dear students, Assalamu alaikum and welcome to Digital Learning at Noor International School. Here your chemistry teacher Fraz Anjum. Today we will discuss chapter number 19, lesson number 1, acid-base theory. In this lesson, our main objectives are define an acid and the base according to the Arrhenius, Bronsted-Lowry and Lewis theory. The resources and object you needed: textbook, notebook and workbook, as well pen or pencil. Let's begin. Arrhenius acid and base. How did Arrhenius define an acid and a base? According to the Arrhenius, acid are the hydrogen-containing compounds that ionize to yield hydrogen ion H positive ion in the solution. Base are the compounds that ionize to yield hydroxide ion or hydroxyl ion OH negative ion in an aqueous solution. What it means? It means that any substance, if you put into the water, it gives the hydrogen ion, it called acid. Hydrogen ion means H positive ion. And if the substance give OH negative ion or hydroxide ion in the water, it's called base. In this lesson, we discuss all the way and explain how it look like and how it's going to be. So these are the most common Arrhenius acids, or most common acid you can say. So let's start one by one. Acid vary in the number of hydrogen they contain that can form hydrogen ions. You can see hydrochloric acid, only one hydrogen. Nitric acid, one hydrogen. Sulfuric acid contains two hydrogen. Phosphoric acid, three hydrogen. Ethanoic acid, all the way four, but there is only one hydrogen can donate. How? We will discuss later. And carbonic acid have two hydrogen. So let's start one by one. First of all, we are using the term ionize or ionizable hydrogen. So what is it? A hydrogen atom that can form a hydrogen ion is described as ionizable. Means, take example of hydrogen chloride or hydrochloric acid. In the hydrochloric acid, you can see HCl have one hydrogen and one chloride ion or chlorine. When it dissolves in water, what will happen? It breaks the bond and gives H plus ion to the water and Cl negative ion to the water. So it means this hydrogen become ionized, or this chlorine or this chloride ion become ionized, means atom become ion, or molecule after the breaking the molecule, atom become ion. So there are two kind of ion, positive ion and negative ion. You know this one, cation or anion, also called hydrogen ion or chloride ion, you can see. So by the basis of this number of hydrogen ion, we can classify the acids into three different groups, which are monoprotic, diprotic and triprotic. Start with the first, monoprotic acid. Monoprotic acid, basically, mono means one. Protic comes from the proton. So monoprotic acid means the compound or the acid who contains only one hydrogen, or who can donate only one hydrogen ion to the aqueous solution. So let's start. Nitric acid is an example of monoprotic ion. In HNO3 has one ionizable hydrogen. Nitric acid is classified as monoprotic acid. Other one is diprotic acid. Di means two, protic means H positive ion or proton. Acid that contain two ionizable hydrogen such as sulfuric acid are called diprotic acid. Look the formula of sulfuric acid, H2SO4. In H2SO4, how many hydrogen? Two hydrogen present. And both can be donated to water. That's why it's called diprotic acid. Now third one, acid that contains three ionizable hydrogen such as phosphoric acid are called triprotic acid. Look at the formula of phosphoric acid, H3PO4. So how many hydrogen there? 3, and all 3 are ionizable. So it means with water it donate all these 3 hydrogen ion and become ionized. So that's why it's called triprotic acid. So one more time, how many acid or how many group of acid we can classify according to the ionizable hydrogen? 3. Number 1 monoprotic, number 2 diprotic, number 3 triprotic. Monoprotic have one ionizable hydrogen ion, diprotic contains two ionizable hydrogen ion, and triprotic contain 3 hydrogen ionizable hydrogen ion. Let's proceed to the next. Now, in an aqueous solution, hydrogen ions are not present. Strange, isn't it? Yes. Earlier I said that when you put the acid in the water, it gives the H to the water. And now I'm saying here is not present. Where it go? Hydrogen ions are not present mean that free hydrogen ion. The free hydrogen ions of hydrogen ions are not present in this solution. Why? Because the hydrogen ions are joined to the water molecule as hydronium ion. So what is hydronium ion? A hydronium ion, H3O positive, is the ion that forms when a water molecule gains a hydrogen ion. Means, look here, HCl. In HCl, hydrogen chloride. Hydrogen donate the H plus ion to the water and it becomes H3O positive. So H plus ion, when it takes, it becomes H3O positive, and this H3O positive called hydronium ion. So there are no free H positive ion present in the aqueous solution. How they present? In the form of hydronium ion. Remember this. Okay, now look here, HCl structure or molecular structure. Check here. White ball indicate the hydrogen. So how many hydrogen here? 1. It give to the water. So it become 1, 2, 3. Okay, so 3 hydrogen. So 3 hydrogen with the positive charge. Okay, so that's why it's called hydronium ion. And what left? Chlorine or chloride ion. So chloride ion you can find in the aqueous solution. That's why we call, after donating H positive ion to the water, it becomes hydronium ion, and because of this reason there are no hydrogen ion present in the aqueous solution of acid. Now let's take the comparison. Methane and ethanoic acid. Methane formula is CH4 and ethanoic acid formula is CH3COOH. Both compound contains 4 hydrogen. Check here, CH4 means 4 hydrogen present, and here CH3COOH means 3 plus 1, 4 hydrogen here. But one between them, one is called acid, other one is called simple compound or organic compound, or it is not an acid. Why? Look here. Methane is an example of hydrogen containing compound that is not an acid. The 4 hydrogen atoms in methane are attached to the central carbon atom by weakly polar CH bond. Methane has no ionizable hydrogen and it is not an acid. So remember this all CH4 bond, CH bond, CH bond, CH bond, CH bond. So how many bonds? 4 bonds can form in methane. All are covalent bond. So the electronegativity difference is very less. Okay, is the difference is very less to become a polar bond. So that's why there is no polarity between them. And then if there is no polarity, means no partial positive or partial negative can be formed, like in HCl we discussed. Now vice versa here in ethanoic acid. Ethanoic acid contains 3 hydrogen here and 1 hydrogen here. So these 3 hydrogen we can say non-polar. There is a no polarity or very weak polar. It cannot donate hydrogen ion from this side. But look here. In this side, hydrogen contains with the oxygen, and oxygen is a very high electronegative element. And the difference of electronegativity cause here partial negative and partial positive. So this partial positive become positive ion and it can donate very easily here to the water. So here you can see ethanoic acid, which is commonly called acetic acid, is an example of a molecule that contains both hydrogen that do not ionize and a hydrogen that does ionize, as I explained here. Although its molecule contains 4 hydrogen, ethanoic acid is a monoprotic acid, means only 1 hydrogen ion can be donated. Look here, as I told you, only this hydrogen can be donated. So how many hydrogen can be donated, or how many hydrogen can be ionizable? Only 1. That's why it's called monoprotic. Although it contains 4 hydrogen, but you can't say tetra or polyprotic. Why? Because here is only 1 ionizable hydrogen it can donate, not this hydrogen. Understood? Good. Now these are the structure. You can see here is a polarity, no polarity here, but this side there is a polarity. That's why we call the 3 hydrogen attached to the carbon are very weak polar bond here. So it cannot be donate the hydrogens here. So they do not ionize. Only the hydrogen bond to the highly electronegative oxygen can be ionized from this side because of oxygen and hydrogen. So this highlighted hydrogen is the only one can be ionized. That's why we call monoprotic acid or monoprotic hydrogen ion. Thank you so much, students. We discussed acid, arrhenius acid, and the properties and the classification. Now next we will discuss the arrhenius base in the next video, and then further on Lowry and Bronsted and Lewis. Thank you so much for watching.